All right, here we go. So section 4.2, it's called congruent figures. Well, you've seen this word before, congruent, right? And you've done some figures. I mean, like any shape would be a figure, all right? So we're talking about congruent figures. Now, up to this point, I've been pretty slack on you guys using the symbol congruent. So for instance, if I said angle A is equal to angle B, I was completely fine with you making it an equals and not a congruent. Okay, would you agree with that? Yeah, I wasn't picky on it at all. I don't know if you remember, but when we first started talking about this congruent thing, I said that some teachers are really, really picky on it, okay, that they would not allow you to put that. What they would have you do, and you've seen this in the book before, and again, I'm not picky about this, but some teachers are, and the books are, so I probably should be. But a lot of times they put a little m in front of that. What does that mean? What does the m mean? The m doesn't mean it's congruent. The measure of, right. I don't talk about it a lot, but I've mentioned it several times, that the little m in front of it means the measure of angle A is equal to the measure of angle B. All right, that's when you can use an equal sign. Everybody with me on that? So when you have the measure of something equals the measure of something else, we're talking about a number. So numbers can be equal to each other. All right? We don't really say that angles are equal to each other. We say that angles are what? Congruent to each other. All right? But again, it's such a fine line that it doesn't bother me. For some geometry teachers, it probably does, but it doesn't bother me if you said that angle A is equal to angle B. It's a very subtle difference, but with all that said, we're talking about congruent figures. What we're going to do now with these congruent figures, I'm absolutely going to be picky about writing the congruent symbol. Remember the congruent symbol? Equal sign with a little squiggly on top of it. Means they're congruent to each other. All right, so let's first of all talk about congruent figures. Congruent figures must have basically two things that are the same. They got to have the same size, and number two, they got to have the same shape. So if something has exactly the same size and exactly the same shape, then they're congruent to each other. For instance, if I took something and I picked it up, and if it can lay exactly on top of the other one, right, and it's a perfect fit, then they're congruent figures. You with me on that? Yes? Okay, pretty simple. Same size, same shape. They fit exactly on top of each other. So for instance, if I took let's take a polygon, all right, and, oops, don't want that. 6-sided polygon, that's fine. Oops. There we go. There we go. If I took this, watch this. Now on this program that I use, like on the board, I wouldn't be able to do this, but on this program I can do this. If I copy, paste, what's true about both of these figures? They're exactly the same, right? Would you agree? Now, they're not the same shape because this shape is right here, this shape is right here, okay? So they're two different shapes, would you agree? But they have the same what? Size, and they have the same shape. Would you agree? So if I took this one, picked it up, and put it right on top of it, there you go. So if you can do that, then what's true about these two figures? They're congruent to each other, okay? So I would say that this thing is equal, or not equal, but what? Congruent to this one right there. They are congruent to each other. They are two different figures. That's what we did up here. So angle A and angle B were two different angles, right? But they had the same exact measurement, so we say that they're congruent. I could take angle A, pick it up, stick it right on top of angle B, right? So yeah, you're right. They are two different figures, but they're congruent, which means if I picked one up and put it on top of the other one, they'd be exactly the same, all right? So they are two different figures, all right? So they're not the same figure. They're two different ones, but everything matches up. Like this side right here matches up with this side right here. You follow me? This here and this here. And this angle right here is equal to this angle right here. Because if I picked it up and put it on top, what if I did this to it? That's really, oops. Let's do this. Okay. What if I did this and just rotated it a little bit like that? Are they still congruent figures? Sure. Okay, because I could pick this up and put it here. I'd have to do a little twisting, right? A little turning of it, but I don't have to make it bigger. I don't have to make it smaller. I don't have to change the shape of it, right? These are still congruent figures. Make sense? Okay. We're basically, especially in this chapter, going to stick with not just any congruent figure, but one particular shape. What do you think is probably the most important shape that we've dealt with so far this year? A triangle, exactly right. Triangles are super important. We use triangles all the time. We even have a whole entire course just on triangles, and that's called trigonometry. You ever hear of trigonometry? That's basically the study of triangles, all right? And there's just so much, a whole entire course, not just a chapter, not just a section, not just a book. Well, yeah, just a book, okay? We got a whole entire course, a book on basically triangles, all right? So triangles are super, super important, and that's what we're going to deal with right now. So right now, we're going to talk about congruent triangles. Congruent triangles. And there's a lot to learn about congruent triangles. In fact, the rest of this chapter is about basically congruent triangles. Maybe the last section, I wouldn't consider congruent triangles. Everything up to the very last section of this chapter would be considered congruent triangles. Okay, so let's make a triangle. I'll just make some random triangle. But what I'm going to do is I'm going to copy and paste it so that I have what? Congruent triangles. Very good. You get the idea. So there's that. I'm going to group it together. So if I just pick it up, it'll move. Now I'm going to copy and paste it. Then I'm going to move it over here. Now again, you can be pretty, if you don't think I'm cheating, okay? I did copy and paste. How do you copy and paste on a computer program? Or Control C and then what's paste? Control V. Why is it V? Why is it not P? P is for print. And V is right next to what? C on the keyboard, okay? So it's Control C, Control V, and that's what I did with both of these. So you know they're identical. Would you agree? Right? You could take this, pick it up, put it right on top of it, bam. It's exactly the same. But there's two different triangles though, right? But they have the same size and they have the same what? Shape, okay? So let's label these triangles. Let's call this ABC. ABC, call this one DEF, DEF. What I'm doing right here is I'm basically just showing you how to write or how to deal with congruent triangles. You know they're congruent because I picked it up, put it right on top, I copied and pasted, all that stuff. You know they're congruent. But how do we know by looking at triangles on a piece of paper? I don't know that the people in the company that made the book copied and pasted it and made it exactly the same. I'm not going to sit there and measure every little thing and measure every angle and all that to see if they're congruent to each other. Okay, I can only go by what they tell me about the triangle. Yeah, we're going to put some lines on there, little tick marks. And we've done this before, right? I've shown that like one angle is equal to another angle by putting that little arc thing. And I showed that one line segment is equal to another line segment by putting those little tick marks. Remember that? Okay, so that's what we're going to do. So let's say this side is equal to this side. And let's see, I went to this one. This side is equal to this one. And this one is equal to this one. All right? So if they're going to be congruent, we call them the corresponding sides. So if I took this, picked it up, and put it right on top of this, which one would be corresponding to line segment AB? What? DE, right. Everybody see that? Because DE and AB would match up. They're called corresponding parts or corresponding sides. Everybody hear me on that? That's really important. That's the first time I've said it, but we're going to talk a lot about this. So they are corresponding sides. Now remember we did the parallel lines cut by transversal. We had corresponding angles. Remember that? It's kind of the same, but a little bit different. But we still use the same word, the corresponding sides, okay? And you could also do this. You could also, since they're corresponding, what angle do you think angle A is equal to over here? Angle D, right? Because if I picked it up, D and A would be right on top of each other, right? And then let's do C next. C and what? F, and then B and E. All right? So you know, those are all the corresponding parts. All right? So we know that, let's write them out, that AB, let's use the congruent part now. So that AB is congruent to what over here? Match them up exactly the same. So if I started from A to B, what would I do over here? I call it what? DE. Now, technically, I could probably call it ED, right? They are the same thing, but I want to match up everything. I want everything to match up exactly the same. So if I start with A and I go to B, what am I going to start with here? D and go to what? E, all right? So DE. Everybody with me? All right, let's do the second side, this one with two arcs right here. So I'm going to call it BC. I could have called it CB if I wanted to, right? I just decided to call it BC. So that would be congruent to what over here? So if I went BC, which one over here matches up with BC? EF. Yeah, it's pretty easy, right? It's not much of a stretch to think about this. And then what do you want to call the last one? Let's call it AC. So what's that going to be equal or congruent to? If I call this AC, what am I going to call this one over here? DF, right. So line segment DF. I'm getting somewhere with this, okay? So those are my corresponding sides. Everybody hear me? They're the sides of the triangle that correspond to each other. It also has corresponding what? Angles, all right? So let's mark those. Again, let's go in order. So we could say that angle A is equal to or congruent to what? Angle D, right? A and D are equal to each other. I mean, we've already established that by putting those little arcs there, but now we're just writing it all out. Let's go B, angle B. Let's try to make it look like a B. There we go. So angle B is congruent to what? Angle E, right. And last one, angle C is congruent to angle F. All right. That's super important. All right. Now, what we're going to do is we're going to label these triangles, and we're going to show that they're congruent to each other. But we're going to be really picky on this, okay? I haven't been picky in the past, but now I'm going to be super, super picky about this. All right. So I could call this triangle, three different ways I could call this triangle, couldn't I? All right. What do you think would be the nicest way to call it? Triangle what? Yeah, let's call it ABC. I could have called it BCA, CAB, whatever. CBA, whatever you want to call it, okay? But here's the part that you got to get right. It's congruent to this triangle over here. But you got to make sure that the corresponding parts match up, okay? Now, technically, I could call this triangle EDF, couldn't I? I could call it FDE. I could call it DFE. I could call it a bunch of things. But since I called this one ABC, I have to call this one only one answer. Okay, I only got one thing that I could call this triangle if I called this ABC. You got to have the parts that match up. So if I went A, B, C, what am I going to have to call this one over here? D, E, F. Everybody see that? Come on. There we go. My marker is acting funny today. All right, so that's what I could call it. A, B, C, and D, E, F. Look, the A and the D match up, right? You see that? They're first. The B and the E match up. They're second. The C and the F match up. They're third. So if I call this ABC, I have to call this DEF. You got it? All right. What if I could call this, I didn't have to call this ABC, did I? Okay, I just asked you what's the easiest thing to call it. I mean, what do you think the weirdest thing to call this would be? CBA, BCA. Yeah, let's go BCA. That's kind of weird. I mean, really, there's nothing real weird about any of it. All right, but we'll call it BCA. So everything's in a different order, right? Now, here's the thing. What am I going to call this one over here? If I called this BCA, I have to call this what? E, F, and D. Everybody see that? E, F, D. And how do you know that's right? Because the B and the E match up, don't they? all right? And the C and the F right there, that one and that one, they match up. The A and the D right there and there, they match up. So that's what you have to call it. If you call one a certain thing, and you could have all kinds. I said 3 different ways. I think there's like 6 different ways you could name this triangle, okay? But no matter how you name this triangle, you've got to name the other one that's congruent to it, and everything's got to be corresponding. The B and the E, the C and the F, and the A and the D all have to be in the same spot. We got it? All right. That's really important. That's why I'm harping on it. All right. It is pretty easy. Let's do this, though. Let's do one. I'll tell you what. I'll use the same triangle. I'll copy it. Now, here's where it gets a little bit confusing. All right. Let's do that. I'll copy it and paste it. Now, what I'm going to do, though, is I'm going to flip it. So I think this transform, no, is it transform? No, that's not what I wanted. What did I did this the other day. Yeah, I'm trying to flip it. Did I?
Can you use your hand with it?
It's not touch. Did I? Oh, there we go. Cool. Yeah, there we go. Flip vertically. All right, thanks. Flip vertically. See what I did? I just flipped it. But now, let's see. Let's just use my keyboard. There we go. So now, if I call it, let's use different letters. I'm tired of ABC. What's your initials?
M-A-B.
What's yours?
E F.
A-F what?
Oh,
We need another initial. Let's go.
MKF.
MKF. All right. MKF. All right. And somebody else that doesn't have any of these letters in it. What's yours? What is it? EJT. All right. So how do you want to go? E. I just put them in random spots, okay? But now let's take a look at this. Everybody look. All I did was flip it. Okay, all I did was flip it. So which angle is equal to angle K down here? So if I make one arc here, which one's going to have one arc down there? Angle T. Remember, again, all I did was just flip it, right? So which one's going to be M? M and what? E. They're the same, aren't they? And then, of course, F and what? J. All right, everybody with me? Now, here's the thing. If I call this triangle, let's call it MKF. We'll stay in order. MKF is congruent to this one right here. Okay? Now, how do I know which one matches up? Well, I should say it this way. Yeah, let's just do it. Let's just do it. So which one matched up with the M over here? So this one's got 2 arcs. So which one has 2 arcs down here? The E has 2 arcs, okay? So we're going to call it triangle E. And then, so that was the M, right? Then the K has 1 arc. So which one has 1 arc down here? The T, all right? And then, of course, what's left over? The F and the what? The J. Everybody see that? So you got to be careful. When they could flip it, they could rotate it, they could flip it horizontally, right? They could do a lot of weird things to it. But if they tell you the stuff that's equal in both of them, you should know which ones match up, all right? So which one would match up with MK down here? ET. ET. Well, I went from M to K, so I went from the 2 to the 1, right? So the 2 to the 1, you'd call it ET, wouldn't you? All right? And we'll call this 2 arcs right here. So which one matches up with the 2 arcs here? Okay, if I go KF, I'm going to have to call this one what? TJ. I'm going from the 1 arc to the 3. You see it? And then from the T to the J, 1 arc to the 3. And then, of course, this would be what? 3 tick marks. Then MF and EJ. Everybody got that? Yeah. Okay. So that's pretty important.
Is it going to get a lot harder than this?
Is it 10 of? Is that one we get out?
Yep. Yeah,
Okay. I don't have enough time to do those examples. Yeah, it'll get harder than this. But, I mean, it's not hard or easy, really. It's just learning something new, all right? We're just learning how how to do this. So I think you should be able to do quite a few of these without me quite finishing this up. So what did I give you to do? 1 to 14? So do as many as you can, all right? So 1 to 14, and it's section 4.2. And then you just find the page. Just look for section 4.2. Look for 1 to 14. Okay, do as many of them as you can, all right? There might be a couple at the end you might not be able to do,
How many lessons
but do as much as you can. You got 37 lessons before Christmas.
before Christmas break?
Yep.